Chapter 12, Sample Problem Number 2. 5 satellites orbit the Earth above the atmosphere. Each has the mass and orbital radius listed below. Consider the forces by the Earth on each satellite. So we want the force exerted by the Earth. So let's just talk about one of them. So we'll draw our blue marble Earth and satellite, let's say A, which is at a distance. We're told a distance, orbital radius, which means distance from this to the center, is r. And it has mass m. And for concreteness, let's remember that the Earth has radius r sub e and mass me. And Newton's law says that the force between two objects, for instance the Earth on the satellite, would be universal constant g times the mass of the Earth times the mass of the satellite over the distance squared. And so we can see all of this is basically, it's some constant times the ratio m over r squared. So we want to just figure out what that is for each of these objects. For case A, which is clearly our baseline case, it's designed to be 1. When we have case B, so case B, we have instead m over 2r quantity squared, which is m over 4 times r squared, which is 1/4 what we have for A. For object C, we have the same kind of thinking, but now we're going to have 2m over single r squared, which is twice what we had in A. So we get a 2 here. In case D, we have 2m, but it's over 2r quantity squared. So we have a 2m on the top, but a 4r squared on the bottom. That's 1/2 times the m over r squared. So this is a ratio of 1/2. And then for case E, we have 4m, but it's over 2r quantity squared, which is 4m over 4r squared, which turns out to be the same as m over r squared, so this is also 1. And now our answer is pretty clearly going to be C is the largest, A and E are the same. Oops, sorry about that. And then D is bigger than B. So we have C greater than A or E, greater than D, greater than B.